wobble. We need to pull it apart, see what's going on. Oh boy. Go ahead and shut it down. I can hear it hitting. So go ahead and unplug it. Safety. Pull it apart and take a look here. Pull this tape off. Pretty smooth. And now we got a couple screws here. Here's the door switch. Service door switch. It looks like someone taped it closed. It probably was given trouble. Go. And let's take a look. Oh yeah. See a pretty good wobble there. It looks like a newer motor to me. Here, let me use my flash on and give some light here. It looks like a newer motor. And it also looks like a newer blower wheel. The blower wheel seems too clean. I think it just came loose and needs to be moved over. I bet you I'd get away with just moving it to the left. Good little bit. Alright, got my tools. Let's see how much room we have here for the thermostat wire to get it out of the way. This one's fine, but this one, not much room, so probably gonna have to, oh, here we go with that. There's this one. That's the one that's real short here. I don't know, I'll have to take those off. Sometimes you can move them up, sometimes you gotta take them off, so here's what it is. Alright, we'll go from there. Just looking here, I don't know if the motor was replaced or not, but still going to try and see if we can move that over. Probably change out this capacitor at the same time. You see all the rust on the bottom of it? That's probably a good idea. Yep, so these are a good idea to take a picture of it. This one, you know, blue, red's on the right, yellow is on the bottom. So that makes it fairly easy, but you know, you can get mixed up on these. So a good idea to take a picture or write it down in some way that you'll remember. So you can disconnect these to make sliding out the blower easier. And it's got a couple screws up there to hold in the whole assembly, which slides out of these deals. So get it going. The 6-in-1 screwdriver works great for this because this little size is the perfect size to get these little screws out that are normally right here that hold our deal in. Oh, it's missing a screw there. That might be some of our reason for some of our rattling. I'll fix that up and hold this out. Oh shoot, I dropped the darn screw. That might be the reason for the other missing screw. Shoot. Okay, so now we've got the two screws out. We can slide the whole assembly forward. And I'm just going to slide this one out enough to try to get access to the motor and take a look inside. And also just wanted to turn the wheel and see if we can, yeah, you can see the wheel seems crooked. We may need a new blower wheel and possibly a new motor. Although it spins pretty good, but you see that? It seems like it's off weight, out of balance. But I'll try, loosen up and see what we can do here. This one I need 2 hands for once I pull it up. I can change the capacitor first here, so that's easy. Take this seal out, or at least loosen it. It's a good idea to discharge the capacitor, pull this little cap off. Just discharge it. Technically it discharges itself, but no harm in being extra safe. There's the other. I can test the old one later, but I'm just going to be changing it because of the rust. There we go. New blower wheel, new blower motor, new capacitor. Alright. Red. That's disconnected. This one. This. Good. This one here. Just gonna cut spice right here. I'll probably actually cut spice here, but just mix that here. Floor motor's free. Protect our floor. Just use the service door as mat. Okay. So I just gotta pull this out. Trick to these sometimes you gotta push down right here to get this to clear so it won't pull out. So sometimes you gotta push this little plate down a little bit. Get past that point. I'm fine.
If you do use the service door as a mat, you want to make sure there's no screws poking through, so remove any screws from it first, because those can poke up into you and do you harm, so something to be real careful for if you're putting one of these service doors on the floor, because a lot of times somebody might use a screw to anchor it and hold it in place, and then you gotta put your hand down and lean on something, and it can do you harm, so be careful. It's probably better to get a big scrap of carpet or trash bag or something to put down instead, but just thought I'd warn you about that. Just want to prevent injuries.
It's a little easier to free this up on the shaft first. I should put my gloves on. 7/18. This will make this a lot easier. 7/18. Usually the blower motors don't have as much trouble as the condenser motors to get them off, so not as bad. But getting the old, we've got to remove the couple screws here. This will make good fast work of that. And out with the old blower wheel. And you just have to make sure that the new blower wheel goes in with the hub on the correct side. Just mimic what we got. Old one. There's the new one. Easy. And it's actually good. Kind of dump everything out, dump all the dirt and here out, and dump it in the box. Again, the blower hub goes on the opposite side of where the capacitor is on this one. Might be different on your unit. Okay. Shorter screws here. one screw was stripped, so I could bigger screw here. And this one has low speed, high speed, but we'll just be using just the hot and the neutral, and we'll cap off the high speed and low speed, similar to what it was. This one was here as it left the center post, so make sure we line that up because we can tell what was where. See, our pipe is in the middle of the motor, so I'll admit that. Today. Okay. Just need to loosen it enough to off here. Position. Line up the flat portion of the shaft with the blade on the blower motor, pass it through. Instead of fighting with it this way, we can just turn it on the side.
With these, you want to avoid pushing too hard. You don't want to push out. It's got like a little insert molly, and if you push down on it, it can actually cause it to pop out of its seat. So you just want to let the drill turn it in, or if you're using a ratchet or a socket or a wrench, just to turn it in without pushing it in. Kind of similar deal when installing microwaves. I've showed you guys that tip on a few different videos.
flat side lined up with our deal and balance it in the center. Tighten this onto the flat portion. Snug. Nice and good. Alright. Now we can hook up our capacitor. We've already trimmed our wiring to pass through. And we can hook our ground wire as well. Capacitor, get the rubber cover somewhere. Capacitor. Ground wire. Where did the screw go? Reversing wires here needed. Everything spins good. And we're ready to feed her.
On this day, outside temperature had reached 121 degrees. Inside this closet was probably 85 to 90 degrees, something like that. So still plenty warm inside, but better than being outside. Of course, I wound up doing that too. So here I was feeding the wiring up through the conduit. It's got the little clamp and the sleeve, and you pass the wiring through the sleeve and into the junction box so that all the connections are made inside the junction box. And then the little clamp gets reset on the bottom of the wire, and that holds everything firmly. It keeps the wires from moving around. It helps, the sleeve helps prevent the wires from getting pinched or rubbing, and then, you know, shorting out, grounding out, and just keeps things nice and tidy. And then the connections, the wire nuts, are made inside the junction box, as that's the proper way to do it, so that any connection point is a place where heat can build up, and so having it inside the junction box makes that much safer, and safer for technician and anybody else, but also safer to prevent, you know, fire hazards and here. Maybe the red wire here. I'm actually going to cut this. One less connection. Yep, one less connection. I had left the piece there to make it indicative that that would be hooked up to the black hot wire. Just kind of, you know, you can take a picture, write things down, or like that one, I left the little piece of wire so I would know for sure that that was the hot to hook up to. Red wires and blue wires often are indicative of a switched hot, so you normally have black as your hot, white's your neutral, and then when you see blue and red, it's often indicative of a switched hot or a transformed hot or a different speed hot. Red's usually your high speed, blue's usually your low speed for blower motors. On ceiling fans, you'll often see a blue wire for your light kit or a red wire from a switch, from a wall switch. So if you have a setup where you have two separate switches, wall switches, one for the light, one for the fan, the black one would usually go to the fan. The red wire is usually from the wall switch, and it usually gets hooked up to the blue wire for the fan light. A lot of ceiling fans, it's just one switch that controls both the fan and the light. In that instance, it's one black wire that gets hooked up to the black and the blue. So it just depends on what your particular setup is, but just kind of explaining the wire colors a little bit.
Oh, that went pretty good.
There are a lot of different applications for HVAC as far as the speed goes. A lot of times low speed is used for air conditioning because you want the refrigerant to be able to absorb as much heat as possible. And then for like hydronic heating, a lot of times it's using high speed because you want the blower to put as much heat into the dwelling as possible. So you want a higher speed to remove more of the heat from the coil as the hot water is traveling through. And then other types of furnaces often have different speeds based on their particular efficiencies and design and calculations and everything. So just a little bit about the different blower speeds there. And the red is usually the high speed for heat, for hydronic heat anyway, and the blue low speed for air conditioning, but not always. In my situation, my setup, it's just one speed, the hot and the neutral. And high speed and low speed is just capped off.
Anchor. Do up here. See the light? Sometimes.
Yep, we went from this to this. Only took about an hour and 15 minutes. Now all that's left is to go back and tape everything up to make it more efficient, and that'll get rid of the tiny bit of whistling, the air being pulled through, little screw holes and little openings around the side. So the tape will make that much more efficient. We're good to go. You don't always need to replace the blower motor. A lot of times you can try moving the shaft. If it has a lot of movement, a lot of play, or when it turns it bumps, or if the bearings sounding bad or whatnot, time to replace the motor. Sometimes you can just replace the blower wheel. Sometimes you've already gone through the work to pull it all out. It may be better to add a new one. It's a judgment call there, and it's up to you. But sometimes you can get away with using the old motor. This one I chose not to, just because there was a little bit of play and I didn't want to take a chance. And sometimes it's just a matter of repositioning the blower wheel. I just did a recent video, indoor blower motor wheel rubbing, loud air conditioner screeching inside HVAC heater closet fix, where I was able to fix it just by adjusting the position of the blower wheel. So you might check that out. Coming soon to Kung Fu Maintenance. Return of the PTAC Power. add a little wiggle room if I was to move it further on the shaft to the left. You can hear it rubbing there.